want you to do something for a second. Right now, wherever you are listening to this, just look at the floor beneath your feet.
And if you're standing, maybe stomp on it. Or just wrap your knuckles on the table in front of you.
Yeah, exactly. Feel that solidity. Now look around the room. Look at the walls, the architecture of the space you're in.
It feels permanent, right? You feel the absolute unquestionable reliability of gravity pulling you down into your chair.
It's incredibly comforting. I mean, the structure of matter, the strict rules of how atoms bind together, the way light bounces off surfaces, these things feel completely permanent.
They do. They feel like the absolute unshakable foundation of reality.
Right. We wake up every day assuming the physics that governed the universe yesterday are going to be the exact same physics that govern it tomorrow.
And it is a profoundly necessary psychological comfort. I mean, if we didn't have that assumption, we literally couldn't function.
Yeah. Our entire cognitive framework it needs that.
Exactly. Our civilization, our biology, it all relies on the premise that the physical laws of the universe are fixed parameters, like a static stage on which everything else plays out.
Right. But what if I told you that every single bit of that comfort is, a lie?
A mathematical illusion, basically.
Yeah. Today, we are looking at some truly terrifying theoretical physics, cosmological models, evolutionary mathematics, all to answer one mind-bending question.
Is the universe trying to destroy itself on purpose?
Exactly. We need to completely shatter this idea of a stable reality right now, because the actual physics suggests that our universe is not a permanent fixture at all.
No, it's merely resting. It's paused in this temporary, incredibly fragile state of energy.
And the floor beneath your feet could simply cease to exist at any moment, which is just a lot to process.
It is the ultimate existential vulnerability. I mean, to understand just how fragile this state of existence is, we have to look past the macroscopic world.
Right, past the table you knocked on.
Yeah, past the atoms that make it up, past the protons and neutrons, all the way down to the foundational layer of reality, which is quantum fields.
Okay, let's start there. Because when most people think of a vacuum, they just think of empty space, a void.
Like an empty box.
Right, like you pump all the air and gas out of a chamber, you remove all the matter, and you are left with absolutely nothing.
That's the classical understanding, yeah. But in quantum field theory, that idea of nothingness just doesn't actually exist.
You can never have a true void.
Exactly. A vacuum, in the eyes of a physicist, is defined as a region of space containing the lowest possible energy state of these underlying invisible quantum fields.
So, imagine the universe is filled with these invisible oceans of energy.
Right. And even when they are as calm as they can possibly be, they are still there.
They're never just gone.
No. Now, if a field is at its absolute global minimum of energy, meaning it has released every possible bit of potential energy, it is perfectly stable.
And that's what we call a true vacuum.
Yes. It cannot decay into anything lower. It's rock bottom. Completely inert.
And here's the terrifying part. That is not where we live.
No, it isn't.
And this brings us back to a specific moment a few years ago. I remember when the Large Hadron Collider finally pinned down the mass of the Higgs boson.
Right, it was a massive media event.
It was a huge celebration in the media. But looking at the actual physics, there was this undercurrent of sheer panic among a specific subset of theoretical physicists.
Oh, absolutely. They were not celebrating at all.
Why? What did they see in that data that terrified them?
Well, the panic came from two very specific numbers. They measured the mass of the Higgs boson at roughly 125 gigaelectron volts.
Okay.
And they measured the mass of the top quark at about 173 gigaelectron volts.
And those numbers are bad.
When you take those two specific values and plug them into the equations that dictate how our universe behaves at unfathomably high energy scales, they basically spell out our doom.
Okay, walk me through the mechanics of that. Why do the weights of two microscopic particles mean the end of reality?
It comes down to how these particles interact. The mass of the top quark is exceptionally high for a fundamental particle.
Right.
And because it's so massive, its interaction with the Higgs field, what physicists call the massive top Yukawa coupling, is incredibly strong.
Hold on, let's define that. What exactly is a Yukawa coupling? Because if I'm listening to this while driving, my brain is already swimming at giga-electron volts.
Fair enough. Think of a coupling as like the strength of a conversation between two fields.
Okay.
The Higgs field gives particles mass. The top quark is constantly talking to the Higgs field, and because the top quark is so heavy, that conversation is incredibly loud.
It's an intense, powerful pull.
Exactly. Now, to understand the future of the universe, physicists use something called beta functions.
Which are what, exactly?
A beta function is essentially a mathematical weather forecast for physics.
I like that.
Yeah, in quantum mechanics, the strength of interactions, the coupling constants, aren't actually constant. They change depending on the energy scale you're looking at.
Oh, wow.
So a beta function tells you how that strength changes as you dial the energy up or down.
So, they looked at the forecast for our universe.
Right. When physicists calculated the full 3-loop beta functions for the standard model, they noticed something terrifying.
Because of that loud conversation.
Yes. This immense pull from the top quark essentially drags the energy potential of the Higgs field downward as you move to higher and higher energies.
The Higgs-quartic coupling, right, is driven toward negative values.
Exactly.
But why is negative so catastrophic?
Because it means the energy landscape of our universe doesn't just slope gently upward forever like the sides of a bowl.
Okay.
At a specific, mind-bendingly high energy scale, roughly 10 to the 10th power giga-electron volts, which we call the instability scale, the math dictates that the energy curve turns back down.
It drops.
It drops, meaning the vacuum state we are sitting in right now, the rules of physics governing your body and the floor beneath you, is not the true bottom.
We're in a false vacuum.
Yes. It is a metastable local minimum.
Okay, let's visualize this so it's tangible. Imagine you are a boulder, and you've been rolling down the side of a massive mountain.
A very bumpy mountain.
Right. Eventually, you come to a stop in this shallow little dimple on the side of the cliff. You look around, you're not moving. Gravity's pulling you straight down into the dirt, and everything feels completely solid.
You feel safe.
You think, great, my journey's over. I've reached the valley floor.
Yeah.
But you haven't.
Not even close.
You were just perched in this tiny, fragile indentation halfway up the mountain. And just beyond the lip of that dimple is an infinite vertical drop into the actual valley below.
That is precisely it. We are that boulder. Our entire universe, all the galaxies, all the stars, every moment of human history has taken place inside that little dimple.
That is deeply unsettling.
The perceived solidity of the floor you just stomped on, that's just the boulder resting in the false vacuum.
But, I mean, if we're resting, we're safe.
Right.
Unless something pushes us over the edge of the dimple.
Well, in classical physics, yes, you would need an immense amount of energy to push the boulder up and over the lip of that dimple.
Right.
But we don't live in a purely classical universe. We live in a quantum one. And in quantum mechanics, things don't just sit still.
There's always some fuzziness.
Exactly. There is a principle called quantum tunneling. You don't actually need to be pushed over the lip of the dimple. You can simply tunnel through it.
Because particles act like waves of probability.
Right.
Right. So there's a tiny non-zero chance that a particle just suddenly exists on the other side of a solid barrier.
You've got it. And it applies to fields, too. If a sufficiently large microscopic region of space randomly fluctuates in its energy tunnels through that mathematical barrier into the lower, more stable energy state of the true vacuum.
It triggers something.
Yes, it triggers something called bubble nucleation.
Okay, so imagine the fabric of our reality is stretched incredibly tight, like the surface of a drum.
Right.
This quantum tunneling is like an infinitesimally small tear suddenly appearing in that tension fabric.
Yeah.
What happens the exact millisecond that bubble of true vacuum forms?
Absolute eradication.
Wow.
Yeah. To understand how fast and how violently this happens, we have to look at the math that governs the transition. Physicists calculate the probability and mechanics of this using something called Coleman-de-Lucia instantons.
Wait, what is an instanton? Because that sounds like a sci-fi weapon.
It really does, but it's a very real mathematical concept. Think of an instanton as a fleeting, temporary bridge between two different states.
Okay.
It's a localized disturbance in a quantum field that essentially acts as the tunneling path from the false vacuum to the true vacuum.
So it's the tunnel itself.
Right. And to find out if this bridge can form, physicists calculate something called the Euclidean action.
Break that down for me. I know action in physics usually refers to the path an object takes through space and time, like the path of least resistance.
Exactly.
But why Euclidean?
That's a great distinction to make. In standard physics, we use Minkowski space, which treats time differently than the three dimensions of space. Time is, mathematically, on a different axis.
Right.
But when you are trying to calculate quantum tunneling, the math becomes almost impossibly complex because tunneling isn't a standard journey through time. It's probabilistic.
Doesn't flow normally.
Exactly. So physicists use a mathematical trick called a Wick rotation.
A Wick rotation.
Yeah. They multiply time by an imaginary number, which converts Minkowski space into Euclidean space.
And what does that do?
In Euclidean space, time behaves exactly like a spatial dimension. It makes the math symmetrical and solvable.
Okay, so it's basically a mathematical cheat code to figure out how likely it is for reality to tear.
Exactly. They look at the tunneling exponent, usually denoted as b. It's defined as the difference in the Euclidean action between the bounce solution, which is that instanton bridge connecting the false vacuum to the true vacuum, and the false vacuum state itself.
Let me make sure I'm wrapping my head around this.
Yeah.
You're subtracting the energy state of where we are now, our fragile dimple, from the energy state of the bridge that forms to the bottom of the mountain.
Right.
And that subtraction gives you the probability of the bubble forming.
You've got it perfectly. And if that tunneling occurs, if the bubble nucleates, the true vacuum, the lower energy state, begins expanding outward.
And here's where it becomes truly apocalyptic.
Yeah, because there is no friction in a vacuum, there is nothing to slow this bubble down.
Not at all.
The immense energy difference between the false and true vacuum pushes the bubble wall outward, causing it to accelerate endlessly until it approaches the absolute speed limit of the universe.
The speed of light.
The speed of light.
So this tear in reality is coming at us at the speed of light, which means, practically speaking, you wouldn't see it coming.
You couldn't. If the bubble nucleated in the Andromeda galaxy right now, the light carrying the visual image of the bubble would arrive at your eyes at the exact same instant as the bubble wall itself.
There is zero warning.
Zero. The sky wouldn't even change color before you cease to exist.
And it doesn't just vaporize matter. I mean, I think vaporize is the wrong word, because vaporizing implies that a solid is turned into a gas, right?
Right, the matter is still there in a gas.
Exactly. The matter is still there, just in a different state. This is so much worse than vaporizing.
Fundamentally worse. The fundamental constants of nature change across that bubble wall.
The actual rules change.
Yes. The forces holding your protons together, the rules of electromagnetism, the mass of electrons, the very architecture of standard model physics, they are systematically overwritten. The Earth, the solar system, your body, your memories, the entire physical structure of our reality is instantaneously deleted and replaced by whatever physics exists in the new, true vacuum.
So you don't burn, you don't explode.
No. The rules that allow you to be defined as matter simply stop applying to the space you occupy.
It is genuinely hard to fathom that level of erasure.
It really is.
We are living in a fragile glass house, and we are just hoping a microscopic quantum fluctuation doesn't shatter it.
Right.
But, looking at the timescales, the standard calculations say spontaneous decay, just waiting for the boulder to naturally tunnel through the rock of the mountain, could take trillions of years.
Statistically, if we assume a perfectly uniform universe, yes.
But, and this is terrifying, but what if we aren't just waiting for a random fluctuation in an empty room?
Because we aren't in an empty room.
Right. Our universe isn't a perfectly flat, empty void.
Mm-hmm.
What if something in the universe is actively acting as a catalyst?
That is the big question.
Like, what naturally occurring thing has enough power to warp this math and try to shatter the glass right now?
This is where we have to introduce gravity into the equations, and specifically the concept of a cosmic impurity.
Okay, an impurity.
Because the math we just talked about, the Coleman-de Lucia instantons, that assumes a perfectly flat, empty spacetime.
Right, the classic spherical cow of physics, assuming everything is perfectly smooth to make the math work.
Yes. In mathematically flat spacetime, the bounce solution, that bridge between the false and true vacuum, possesses a mathematically perfect O4 spherical symmetry.
Okay, pause. Let's explain O4 symmetry. What does that actually mean in plain English?
Imagine a perfectly round soap bubble. In 3 dimensions, we call it O3 spherical symmetry.
Okay.
No matter how you rotate it, it looks exactly the same. The pressure inside is perfectly balanced against the surface tension outside.
Got it.
O4 symmetry is the exact same concept, but mapped across 4 dimensions, 3 of space and 1 of Euclidean time.
Oh, wow. Okay.
It's a perfectly symmetrical sphere of mathematical probability. And under what we call the thin wall approximation, the rate at which our universe might decay is determined by a tug of war between 2 things.
What are they?
First, the energy difference between our false vacuum and the true vacuum. That difference acts as an outward pressure, trying to push the bubble to expand.
Like blowing air into the soap bubble.
Right. And second, the surface tension of the bubble wall itself, which is trying to crush the bubble back out of existence before it can grow.
Okay, so it's a constant battle, and normally If we add gravity to this perfectly symmetrical tug of war, gravity is actually our friend, right?
Surprisingly, yes. When you calculate the gravitational back reaction and add it into these equations, gravity generally makes the probability of vacuum decay much smaller.
It holds things together.
Exactly. In some theoretical models, if the energy difference between the vacuum is minimal, gravity can actually completely stabilize the false vacuum.
It anchors the boulder in the dimple.
Yes, it prevents the nucleation of that zero energy bubble altogether.
So, gravity saves the day. We can all breathe a sigh of relief, except, as we establish, we do not live in a perfect, flat, empty universe.
Far from it.
We live in a universe filled with extreme, hyper-localized gravitational distortions. And this brings us to what might be the ultimate apocalyptic trigger, which is primordial black holes.
Exactly. And to understand why they are so dangerous, we have to differentiate them from normal black holes.
Right, because when people hear black holes, they usually think of stellar mass black holes, a massive star that burned out all its fuel and collapsed under its own weight.
Right. But primordial black holes, or PBHs, are entirely different. They are theoretical objects that formed in the very first fractions of a second after the Big Bang.
Before stars even existed.
Long before.
Yeah.
The early universe wasn't perfectly smooth, right? There were extreme fluctuations in the density of energy.
Okay.
Some microscopic regions were so densely packed with energy that they instantly collapsed into black holes without ever needing to be a star first.
Wow.
And because of that, they can be incredibly small, microscopic even.
And these microscopic black holes act as nucleation seeds. They are impurities in the fabric of spacetime.
Let's go back to our perfect soap bubble, our perfect O4 spherical symmetry of the bounce solution.
The four-dimensional bubble.
Right. In a flat universe, that bubble of probability is incredibly hard to pop because the tension is distributed perfectly evenly across its surface.
Okay.
But when you introduce a primordial black hole into the vacuum, its intense, hyper-localized gravity violently warps the spacetime around it.
So it's not a smooth surface anymore.
No, not at all. It completely breaks that standard O4 symmetry. It replaces that perfect mathematical sphere with a localized, jagged distortion.
So instead of trying to pop the soap bubble by squeezing it evenly with both hands, which is hard, it's like a microscopic grain of sand hitting the bubble.
Yes.
It creates a localized point of infinite curvature.
Yeah.
It gives the pressure a specific, sharp point to concentrate on, drastically reducing the energy required to rupture the surface tension.
That is an excellent analogy. By breaking the symmetry, the primordial black hole acts as a catalyst. It exponentially increases the quantum tunneling probability.
It just wrecks the math that was keeping us safe.
Exactly. It drastically lowers the energy barrier needed to rip reality open. The black hole provides the exact environmental conditions necessary for the false vacuum to easily slip into the true vacuum.
And looking at the actual numbers on this, there is a specific mass threshold here that is just purely terrifying. It's not just any primordial black hole that triggers this.
No, theoretical models that compared the decay rate of the false vacuum to the Hawking evaporation rate of black holes reveal a very specific critical intersection.
Okay, what's the number?
A primordial black hole with a mass of exactly 4.5 times 10 to the 14th grams.
Wait, let me translate that so people can visualize it. 4.5 times 10 to the 14th grams is roughly the mass of an entire large mountain, like Mount Everest.
Pretty much.
But because it's a primordial black hole, that entire mass is compacted down into an event horizon that is smaller than a single atom.
Yes. It's an atom-sized mountain.
Yeah.
And a black hole of exactly that mass has a theoretical lifespan that perfectly matches the current age of our universe.
If you are making coffee right now, or walking the dog, just pause and think about what that means.
It's sobering.
If this microscopic object was created at the dawn of time 14 billion years ago, and it has that specific mass of an atomic-sized mountain, it is reaching the very end of its life right now, today.
And this is where we have to talk about how black holes die, because they don't just sit there forever, they die through Hawking radiation.
Right.
As a black hole sits in space, quantum fluctuations near its event horizon cause it to slowly leak energy. It evaporates. And as it evaporates, it shrinks. It loses mass.
But counterintuitively, as it shrinks, it gets hotter. Why does it get hotter?
It comes down to black hole thermodynamics. The temperature of a black hole is inversely proportional to its mass.
Oh, weird. Okay.
Yeah, a supermassive black hole is incredibly cold. But as the black hole evaporates and its mass decreases, the surface gravity at the event horizon actually increases.
Which accelerates the emission of Hawking radiation.
Exactly. It becomes a runaway feedback loop. As it loses mass, its temperature and its localized energy density spike violently. It gets hotter, more erratic, and it radiates energy exponentially faster.
This is the part that gives me chills. Right at the end of its life, in its final throes of evaporation, when it's shrinking out of existence, the black hole's temperature spikes so high that it crosses the exact mass range where seeded vacuum decay completely dominates over standard evaporation.
It stops just being a dying black hole.
It becomes the perfect, unstoppable trigger for the apocalypse.
It becomes a hyper-concentrated point of chaotic energy. A single primordial black hole, completely invisible, microscopic, dying quietly somewhere in our solar system today, could be the catalyst that triggers the bubble nucleation.
That's horrifying.
It evaporates, the O4 symmetry breaks, the energy barrier drops, the bubble nucleates, and the light speed apocalypse begins.
Just one microscopic impurity quietly fizzling out in the dark, and our physics are overwritten forever.
That's all it would take. One seed.
But, this raises a profound question about the nature of this apocalypse itself. We keep saying the true vacuum expands and overwrites our physics.
Right.
We tend to conceptualize this expanding bubble as just a wave of death, empty nothingness, the ultimate void.
Sure, that's the natural human assumption.
But what actually exists inside that expanding bubble? If it's a true vacuum, what does the physics of a true vacuum actually look like?
That is where the physics shift from cosmic horror to something unimaginably strange, because mathematically it isn't necessarily a void.
What if this expanding true vacuum, let's call it the novo-vacuum, isn't just an entropic wasteland?
Right, what if it's not just empty?
What if it is a staggeringly complex, exotic ecosystem built on entirely orthogonal physical laws?
When we talk about overriding fundamental constants, we aren't just talking about turning off the lights and leaving an empty room.
Exactly.
The novo-vacuum would possess its own topological structure, its own forces, its own geometry. The rules are different, but there are still rules.
Let's try to visualize the architecture of this new reality. Let's look at the absolute limit of scale, down at the Planck length, 10 to the negative 33 meters.
The smallest possible pixel of space.
Right. What does space look like in the novo-vacuum down there?
At that scale, in this hypothetical novo-vacuum, the smooth, continuous spacetime we are used to in our universe is replaced.
Replaced by what?
Instead of a continuous fabric, imagine a hyperdimensional, discrete quantum graph structure. Microscopic nodes and edges connecting in ways that completely defy standard three-dimensional geometry.
So spacetime itself is pixelated. It's not a sheet, it's a web.
Yes. And we can conceptualize these foundational building blocks, these discrete nodes of reality, as Vendex.
Vendex. Little geometric knots of reality, like the code that makes up the matrix of this new universe.
And just as our subatomic particles, quarks and electrons bind together through fundamental forces to form atoms and molecules, these Vendex agglomerate too.
They clump together.
They combine to form incredibly complex structures at slightly larger scales, say around 10 to the negative 27 meters. We can refer to these larger complex structures as xenobes.
And reading about the extrapolations of these theories, these xenobes aren't just dead matter, are they?
No, they aren't just inert rocks.
They behave with a level of complexity that mimics multicellular organisms.
Yes. But they are governed by completely alien mechanics. In our universe, matter is governed by mass, velocity, gravity, electromagnetism.
The stuff we know.
Right. Xenobes don't have mass or velocity in any way we would understand them. They are governed by what theorists might call law momenta.
Law momenta, okay.
They are bizarre, self-organizing mathematical principles that dictate how these structures interact, replicate, and form networks. It is a system that allows for immense complexity, completely independent of our standard model of physics. It is essentially an ecology of the void.
Let me see if I can translate law momenta into something I can mentally grasp.
Give it a shot.
Instead of a ball rolling down a hill because gravity pulls its mass. Imagine Conway's Game of Life on a computer screen.
Oh, that's a good one.
Right. The pixels turn on and off based on a strict set of mathematical rules, creating complex, moving patterns, even though the pixels themselves don't have weight or physical momentum.
Exactly.
The xenobes move and interact based on pure mathematical logic written into the novo-vacuum itself.
That is a very apt analogy. It's an ecosystem of pure, discrete topology.
An ecosystem that is currently, hypothetically, swallowing our universe. Now, let's imagine a terrifying variance in the physics of this apocalypse.
Okay, what kind of variance?
Standard theory, as we discussed, says a bubble expands at the speed of light, so you never see it coming. It's instantaneous. But what if the specific gravitational instability that triggered it, the dying black hole? What if the localized drag from that actually causes the bubble wall to slow down? What if it expands at exactly half the speed of light, 0.5 c?
Oh, that changes the entire psychological and existential nature of the event.
Dramatically.
It moves it from a sudden, unknowable death to a known, creeping reality.
Exactly. It's no longer an instant flash of non-existence. It is an agonizingly slow, visible tidal wave.
Because it's moving slower than light, the light from the boundary reaches us before the boundary does.
Yes. You could look through a telescope and literally watch neighboring star systems just wink out of existence.
You could chart its progress over hundreds of years as it steadily overwrites the Milky Way.
It is a slow, creeping doom.
Which forces a civilization into a very unique, horrible corner. It's not a sudden death anymore. It's an approaching border, a visible boundary between two utterly incompatible realities.
And that approaching border frames the ultimate existential dilemma. I want to put you, the listener, in the ultimate seat of power for a second.
Okay, let's hear.
Imagine humanity has advanced hundreds of years into the future. We see the border coming, and we have advanced to the point where we actually possess the technology to manipulate local spacetime.
We have the tools.
Right. We could, theoretically, build a gravitational perimeter and collapse the boundary of the novo-vacuum. We could annihilate it and stop the expansion. The question is, do we have the right to?
It creates a massive ideological schism. I mean, if faced with that reality, you would inevitably see the rise of two radically opposed philosophical factions.
Break them down for me.
First, you have the preservationists.
The survivalists.
Yeah.
The ones who want to pull a trigger.
Exactly.
Yeah.
Their argument is entirely pragmatic and, from a human perspective, completely logical.
They want to live.
Right. They see the novo-vacuum as a destructive cosmic contagion. It is a tumor eating our universe.
So cut it out.
Their ethical imperative is to collapse the border, restore standard spacetime, and annihilate the anomaly at any cost to save our own physics, our history, our art, and our continued biological survival.
It's self-defense on a cosmic scale. If a bear is attacking you, you shoot the bear. If a new universe is attacking you, you shoot the new universe.
It's very cut and dry for them.
But then you have the opposing side, the yielders.
The yielders look at the novo-vacuum and they don't see a tumor. They don't see a void.
What do they see?
Through their instruments, they see the Vendex. They see the Xenovs. They see an unimaginably complex ecosystem harboring potentially conscious, incredibly advanced structural life.
To the yielders, destroying the novo-vacuum to save our own skin isn't self-defense.
No.
It is an act of cosmic genocide. You are wiping out an entire universe of alien topology, potentially trillions of life forms, just because their physical laws are incompatible with ours.
You are destroying a superior complexity just to maintain the status quo of our aging universe.
It is the ultimate clash between the preservation of the self and the reverence for infinite ontological diversity.
It's a horrific choice.
But let's play this out. If the yielders win that argument, and we allow the novo-vacuum to consume us, how do you survive a reality that operates on different fundamental physics?
You don't take your biological body. That is the first hard truth.
Flesh and blood won't work.
Flesh, blood, carbon atoms, the electrical synapses in your brain, they simply cannot exist across that boundary. The fundamental forces holding atoms together do not apply there.
So you just fall apart.
Worse. If your biological body crosses the threshold, it is unraveled into meaningless mathematical noise.
So you have to literally translate human consciousness into the substrate of the novo-vacuum itself.
Yes.
You would have to map the pattern of the human mind, digitize it somehow, and upload it into those Vendeq-based computational structures just across the border.
Exactly. It evokes the concept of the Kantian sublime. The philosophical idea that the sheer terror of an infinite, incomprehensible force can be transcended by the extraordinary rational and cognitive powers of the mind.
Mind over matter.
By mapping our consciousness onto their physics, we don't die, we adapt, we transcend our biological limitations and become part of the new topology.
I have to push back on this, though. I'm trying to imagine what that would actually feel like, and it seems impossible.
It's definitely hard to conceptualize.
How could a human mind even begin to process an orthogonal reality? I mean, our entire cognitive framework, the concepts of up and down, past and future, cause and effect, memory is built entirely on the physics of our universe.
Of course.
Our brains evolved to understand 3 dimensions and linear time. If you map a human mind onto a Venn diagram structure governed by law momenta instead of time and space, aren't you fundamentally breaking the mind?
That is the true terror of the crossing. And to understand why it's so terrifying and why the human mind wouldn't simply act like software running on new hardware, we have to look at differential geometry.
Okay, lay it on me.
Specifically, we need to understand the concept of child's ladder and parallel transport.
Okay, I love a good geometry problem. Let's break this down. Walk me through it.
In general relativity, space isn't a flat grid like a piece of graph paper. It's a curved manifold.
It's bumpy.
Right. Imagine you are trying to carry an arrow, a mathematical vector pointing straight forward, while walking over the hills and valleys of a very rugged, mountainous landscape.
Okay, I'm holding my arrow.
If you want to keep the arrow pointing in the exact same relative direction, keeping it parallel to its original path, you are performing what mathematicians call parallel transport.
Got it.
Mathematically, this means the covariant derivative of your vector along the curve is 0. In shorthand, dv over dt equals 0.
So I'm trying to maintain my orientation, my sense of direction, while the geometry underneath my feet twists and bends.
Exactly. And child's ladder is a discrete geometric method for approximating this transport without relying on incredibly complex analytical calculus.
How does it work?
You use short, straight-line segments geodesics to build a sort of ladder along your path, constantly adjusting your arrow based solely on the local curvature of the ground right under your feet.
Okay, I have my arrow. I'm adjusting it as I walk over the hills. How does this relate to translating a human mind into a new universe?
Because in a curved space, there is no absolute canonical way to identify the space at point A with the space at point B.
What do you mean?
If 2 people start at the exact same spot on the globe, facing the exact same direction with their arrows pointing dead ahead, and they take 2 completely different paths to get to a new destination.
Okay.
When they meet up, their arrows will no longer be pointing in the same direction.
Wait, really? Even if they both kept their arrows parallel to their own path the whole time?
Yes, because the journey itself changed their orientation. The discrepancy between the transported vector and its origin is dictated entirely by the curvature of the space they traveled through.
That is wild.
This phenomenon is quantified mathematically by the Ambrose-Singer theorem. Now apply this as a direct analogy for the human mind moving through the boundary of the novo-vacuum.
Oh, wow. So the human consciousness, the core identity of who I am, is the arrow.
Yes. When you translate your mind into the Venn diagram topology, you are essentially parallel transporting your identity across a vastly alien manifold.
Yep.
You are trying to carry your sense of self across an unimaginably curved and distorted reality. But because of the fundamental rules of geometry, the sheer act of existing and moving through this orthogonal spacetime physically and cognitively alters you.
You literally can't help it.
You cannot maintain your original psychological orientation.
Because the geometry of the new physics bends your thoughts. It bends your logic.
Exactly.
If memory operates on law momenta instead of chronological time, remembering your past fundamentally changes the structure of your mind.
Exactly. Just as the Ambrose-Singer theorem dictates that a vector must change its orientation based on the curvature of the area it traverses, moving through the novo-vacuum causes the self to undergo profound ontological divergence.
You become something else.
To survive the apocalypse, you have to fundamentally lose your original identity. You don't arrive on the other side as you. You become something completely alien just by the sheer act of existing there.
That is chilling. The idea of an alien ecosystem slowly eating our universe, forcing us into a state of profound psychological divergence, where we lose our humanity just to survive it. It's terrifying enough if it's just a random accident.
Right, if it's just a random quantum fluke.
If it's just a dying primordial black hole rolling the cosmic dice and popping the soap bubble.
But what if this highly complex, exotic topology wasn't an accident at all?
This is where we have to zoom out. We have to pivot from the micro scale of quantum mechanics and black holes up to the macro scale of evolutionary cosmology. Because I refuse to believe that a microscopic black hole with a mass of exactly 4.5 times 10 to the 14th grams, triggering a vacuum decay that spawns a highly complex Venn diagram ecosystem, is just bad luck.
It seems a bit much, doesn't it?
That feels too perfect. It feels designed.
And that intuition leads us directly into theories of cosmological evolution. We often think of universes as static, isolated things.
Right.
But physicists have proposed that universes might actually undergo an evolutionary process on a massive multiversal scale.
Like Darwinian evolution, but for reality itself.
Precisely. The core mechanism proposed is this. When a massive star collapses at the end of its life, it forms a singularity, right? A point of infinite density, a black hole.
Yes.
But in these evolutionary models, the singularity at the heart of that black hole doesn't just crush matter into nothingness and stop. It acts as a seed.
A seed for what?
The intense gravitational collapse creates a space-time rupture that bounces. It births a brand new baby universe on the other side, expanding in its own isolated dimension.
It's a cosmic reproductive cycle. Black holes are basically the reproductive organs of the universe.
Yes. And here is the crucial biological parallel. When this baby universe is born, its fundamental physical constants, the speed of light, the mass of the electron, the strength of gravity, they aren't perfectly identical to the parent universe.
They mutate.
They mutate slightly during the extreme physics of the bounce.
Genetic drift, but for physics.
Exactly. Now, if we apply standard population dynamics to this multiverse, we can use something called the price equation.
Hold on. The price equation is from evolutionary biology, right?
Yeah.
It's used to track genetics. How does that apply to universes?
Mathematics is universal. The price equation described how traits change in a population over time based on how much those traits correlate with fitness.
Okay, I follow.
If a trait helps you reproduce, it becomes dominant in the population. In this multiversal landscape, what defines fitness?
The ability to reproduce. And if reproduction happens through black holes, then the fittest universe is the one that makes the most black holes.
Precisely. According to the price equation, the dominant universes in the multiverse, the ones that will vastly outnumber all others over deep time, are those whose physical parameters are perfectly fine-tuned to create the absolute maximum number of black holes.
Wow. We always look around our universe and think it's incredibly fine-tuned for complex chemistry and biological life.
Right, the entropic principle.
We think we are the point. But under this theory, biological life is just a random byproduct, a little mold growing on the side of the machine. The real optimized trait of our universe is stellar collapse. We exist in a universe built to manufacture black holes.
Which brings us to the terrifying intentionality of vacuum decay. Let's look at the future of our universe under standard physics. If left alone, what happens?
Well, we have billions and billions of years ahead of us. Stars will slowly burn out. Galaxies will drift apart as the universe expands. Eventually, all the gas and dust will be used up. The universe will expand, cool down, and slowly succumb to entropy.
The heat death of the universe.
Right.
A slow, stagnant, infinitely long fade into a cold, dark void where no energy moves and nothing happens.
But vacuum decay, this expanding bubble of the novo-vacuum, actively eradicates that downstream future.
It cuts it short.
It sweeps through at the speed of light, or half the speed of light, and violently ends that slow entropic death. Now, if our universe's primary evolutionary drive is to produce black holes, a slow heat death is incredibly inefficient.
Yeah.
It's a massive failure.
And it represents an immense loss of potential reproductive energy. A cold universe doesn't reproduce.
So who triggers the vacuum decay? What if the dying primordial black hole wasn't just a random impurity? What if it's the architects of doomsday?
We are talking about superintelligent descendants from our own far future, entities that have evolved billions of years from now.
Let's call them the blues. These genetically altered post-physical entities capable of manipulating quantum physics and temporal mechanics.
Okay, the blues.
They exist deep in our future, looking out at the slow, cold, useless heat death of the universe. They understand the evolutionary imperative of the cosmos, and they deem the heat death a failure.
Because, as you said, a dying, stagnant universe doesn't reproduce. It is an evolutionary dead end.
Exactly. So the blues realize that to fulfill the ultimate multiversal imperative, the current physical laws must be destroyed. The realization hits with the force of a supernova. The vacuum decay sweeping our galaxy isn't an accident. It's completely intentional.
It's manufactured.
Our own future superintelligent descendants deliberately reached back, manipulated the quantum fields, gathered a primordial black hole, and induced the collapse of the false vacuum to end the universe.
They initiated the apocalypse on purpose. And to understand why that isn't just an act of cosmic nihilism, why they aren't just destroying things for the sake of destruction, you have to look at the mathematics of how the true vacuum actually expands.
It reveals something else.
It reveals an act of supreme cosmic fecundity.
Break down the mechanics of this harvest. I understand how stars dying makes black holes. How does destroying the entire universe create more black holes?
Because the expansion of the true vacuum, especially when manipulated or triggered artificially across vast scales by a superintelligence, isn't necessarily perfectly uniform.
It's not a perfect sphere.
No. As this apocalyptic phase transition sweeps through the cosmos, overwriting our physics, it can fragment. The boundary wall isn't always smooth. As it engulfs galaxy clusters, it leaves behind isolated pockets. Islands of our old false vacuum, completely surrounded by the new novo-vacuum.
Like bubbles of air trapped inside expanding ice.
Yes. But these pockets of the old universe are now subjected to the immense, terrifying relative energy density of the new physics surrounding them.
They're under pressure.
The pressure differential between the false vacuum island and the true vacuum ocean is mathematically incomprehensible.
Because the surrounding space is at a fundamentally lower energy state, these trapped pockets of high-energy false vacuum are incredibly unstable.
Instantly unstable. Under that immense relative pressure from the surrounding novo-vacuum, these remnants of our old universe instantly collapse under their own gravity.
They just crush inward.
Every single isolated pocket of the old physics instantly crushes inward to form a black hole.
Oh my God.
We are talking about an unimaginable number of black holes. Trillions upon trillions of them, born in a fraction of a second across the entire cosmos.
Let's synthesize this. Let's look at the sheer scale of the harvest. Under normal, slow, stellar evolution, over trillions of years, our universe might produce, say, a billion black holes naturally. One dying star at a time. It's a slow drip of cosmic reproduction.
But by intentionally triggering false vacuum decay, the blues, our post-physical descendants, convert the entire universe into a fragmented matrix that instantly buds off magnitudes more black holes than could ever be produced by standard stellar processes.
They're accelerating it.
They vastly outstrip natural evolution. They optimize the system.
They turn the universe into a bomb of baby universes, which leaves you staring into the void with a completely different perspective. The destruction of our reality, the overwriting of our physical laws, the complete obliteration of everything we have ever known. It is not a cosmic tragedy.
No.
It is not an accident.
It is the ultimate biological imperative playing out on a multiversal scale.
Our universe doesn't want to survive a slow, cold heat death. It wants to reproduce. It wants to maximize its progeny. And the intentional violent death of our reality is simply the necessary biological sacrifice to create a storm of mind, to birth countless new universes in the fires of vacuum decay.
It's a very humbling thought.
Which forces you to ask yourself a terrifying question. Are we just temporary biological catalysts? Are we just complex enzymes living in a fragile glass house, utterly meaningless in the grand scheme of things, waiting for the universe to decide it's finally time to breed? Think about that the next time you stomp on the floor, relying on the illusion of permanence. Feel the gravity, trust the atoms, because it might just be the quiet moment before the glass shatters.